Okay, here we go with the notes for 5.1. This is literally the third time I've done this, so let's see how it goes. So, as we define composite functions, or the composition of functions, what it means is you're putting two functions together, not with addition, not with subtraction, multiplication, or division, but you're composing them by plugging one function into another function. There are a couple of notations for that. If we want to look at a composite function, here's the notation that the book uses most of the time. It does not say fog. It's F and then a little circle and G. I read this F of G. I think that's the best way to read it. I know it says F composed with G, which is really what you're doing, but if you think of this as F of G, I think it'll be easier for you. Here's the definition. F of G of X is equal to or means the same thing as F of G of X. So you remember when we first started talking about functions and we found maybe F of 2. What that really meant is you plugged 2 into F. If we found F of negative 3, what did that mean? It meant you plugged negative 3 into F. If you plugged in 0, if it was F of 0, you plugged in 0 to F. All this means is we're plugging our G of X function into F. So composition means you're plugging one function into the other function. Doesn't mean multiplication. Down here, it's just kind of showing you what a function means. If I take X, so if I wanted F of G of X, what it really means is I would be taking X, plugging it into G, taking that answer and plugging it into F. That's really what it means. If you look at it up here, you take X, plug it into G, take that answer, plug it into F. Take X, plug it into G, take that answer, plug it into F. That's really all you are doing. So we're not going to do all the examples. I'm not going to do all of the algebra. You could do the algebra on your own. So if we're going to do a couple of these, this says that I want to find F of G of 1. Two ways to do that. The first way would be to first find F of G of X. Let's write it in the other notation here. If I wanted to find F of G of X, all that means is I'm going to plug G, my function G, into my F. So if I take my function G, plug it into F, here's what it would look like. 2 times 4x cubed plus 1, plus 3. So 2 times 4x cubed plus 1, don't forget to square it, plus 3. And if you did the algebra, you would FOIL out the binomial, so that would be 16x to the 6th plus 8x cubed plus 1. And then if you distribute it and combine like terms, you're going to get 32x to the 6th plus 16x cubed plus 2 plus 3 would be plus 5. So this is my function F of G of X. Now if I just want to find F of G of 1, I would simply take a 1 and plug it into here. So if I take a 1 and plug it into there, I'm going to end up with 32 plus 16 plus 5. When you add those all together, you're going to get 53. So that's the long way of doing it. Another way to do it, and we're going to go and we're going to do this one right here, is to simply, whenever there's a number here, simply take that number, plug it into F, take that answer, plug it into G. So if I take 1 and plug it into F, you can see if I take 1 and plug it into F, what am I going to get? I'm going to get 5. Then I take the 5 and I plug it into G. 5 cubed is 125 times 4 is what? 500. 500 plus 1, you would get 501. Let's go to this last one and do the same thing. Again, what am I going to do? I'm going to take -1 and I'm going to plug it into G. Well, if I plug -1 into G, -1 cubed is -1 times 4 is -4 plus 3 is -3. So taking -1, plugging it into G, I'm going to get -3. Take -3 then and plug it back into G. If I plug in a -3 for G, -3 cubed is -27 times 4 is -108. Better write that down. Plus 1 is going to give me 107 negative. If I were to do this one, you would take -2, plug it into F, take that answer, plug it back into F. For example 2, they kind of give you a visual as to what's going on when you do that. So for example, if I were to take -2, plug it into G, I would get 4. Then I would take that answer and plug it into F, and when I plug it into F, I get 7, or the output is 7. So when in the beginning I take a -2 and I plug it into my composition function, I end up at 7. Okay, I'm going to back out just a little bit. Let's do this one. If I take -1, plug it into G, it tells me I get 1. Then I take that 1, plug it into my F function, I end up at 4. So -1 input ends up with an output of 4. We'll do one more. How about if we do the 2? If I take if I take 2, plug it into G, it gets me a 4. And then if I take that 4, plug it into F, that's going to get me a 7. So 2, oh, they don't ask for that one, do they? Well, let's try that again. Let's do the 1. If I take 1, plug it into G, I get 1. Plug that 1 into F, I end up with 4. So a 1 at the beginning ends me with a 4. So that's how you do that. It's kind of a visual of what's going on. So now, notice in this example, we are given the same F and G that we were given on the previous page, but this time we're not finding them for specific values like -1 or 0. We're finding them just the functions that contain the x. So I've actually already done, I believe, let me look. Yeah, I've already done this one on the previous page. You can see I plugged G into F. So I'm going to do this one for you. This one, I want to find G of f of x, which means that I plug my f function into G. So if I plug my f function into G, let's see what that's going to look like. Well, it will be 4 times 2x squared plus 3 cubed plus 3. Nope, plus 1. Because I'm taking my f function and I'm plugging it into G. Now we do the math. So I need to cube this out. Well, this will be fun. So I'm going to leave one of them alone, and then I'm going to square 2x squared plus 3. So that's going to give me 4x to the 4th plus 6x squared plus 9. There goes my pencil. And then plus the 1. Now I'd have to double distribute this. So I'm going to go ahead and do that. I would get 8x to the 6th plus 36x to the 4th plus 54x squared plus 27. I'm not going to show you all the work for that double distributing. You should be able to do that. Now if I distribute through, I'm going to get 32x to the 6th plus 144x to the 4th plus 216x squared plus 108 plus 1 would be 109. So there is my function g of f of x. Now, notice it also asks me to find the domains. Well, this one's easy. If the two domains of your original function are both all real numbers, which they are in this case, then automatically the domain of your composition function will also be all real numbers. No issue. Let's go on to example 4, though. Notice for example 4, first of all, they don't ask us to actually find the composition function. All they ask you to do is find the domain. So listen carefully and replay this 3 or 4 times if you need to. The first thing that you want to do is look at the domain of each of your individual functions, f and g. So if I look at this function, I know that my domain is going to be everything except for -4 to eliminate the possibility of the 0 in the denominator. G of x, my domain, will be everything except for +2. So now, that's going to be, those are 2 restrictions on our domain. Now, here's the tricky part. What you have to do is you're going to find another restriction. Remember, if I were to actually find the composition function, I would be plugging my g in here for x, which means, listen carefully, that this expression cannot equal whatever the value was for x that I could plug in and make this denominator 0. That is -4. So if x is -4, it means that my f function is undefined, which means that 4 over x minus 2 cannot equal -4. And that's what you do to find another restriction. You're going to take 4 over x minus 2 and set it equal to -4. Cross multiplying, you get -4x plus 8 equals 4. -4x equals -4, x equals 1. So in my composition function, if my x value was 1, I would also have a 0 in the denominator. So that means another value that my x cannot be is 1. So what is the domain of my composition function? Well, it'll be all x's except for -4, 2, and 1. Let's write that in interval notation. It would be all values from -infinity to -4. Skip over -4, so from -4 to 1. Skip over the 1, so from 1 to 2. Skip over the 2, so from 2 to infinity. All right, let's go down to example 5. So again, it says this time we're actually finding the composition functions, so we'll do that, and then we're also finding the domains. Well, let's talk about the domains of each of the individual ones first. This, your x cannot be 0. Remember, if you have a square root, you can't have a negative number in there. So for this, our x has to be greater than or equal to 1. So let's go ahead and let's find the domain of this one right here. If I want to find the domain, remember these are included, but now also I have to take my g of x function, and that cannot equal 0. Which means the square root of x minus 1, if I take that and set it equal to 0, square both sides, add 1. For f of g of x, not only can we not have 0 in the denominator, we also cannot have 1. Now let's actually find f of g of x so you can see that. If I want to find f of g of x, what does that mean? It means I'm going to plug my g function into my f function, which is going to look like 1 over the square root of x minus 1. So what would happen if that x was a 1? Well, you would have the square root of 0, which would give me 0, which is okay in this function. It's not okay here because we have a denominator, and we can't have that denominator of 0. So if I put all of these together, remember x can't be 0. This one says x has to be greater than or equal to 1. So in other words, that kind of swallows that one up. But then since x cannot equal 1, my domain is parentheses 1 to infinity. And you can see that from here. I can have not a 1, but I can have anything greater than a 1. Let's quickly look at f of f. Well, if I plug my f function into my f function, what's that going to look like? Well, it would be 1 over x. And what is 1 over x? It is simply x. So there's your f of x. But when we list the domain, we have to take into account that originally x could not equal 0. So that means that x still cannot equal 0 because you have to include the domains of each of the original functions. In this case, simply this one, because that's the only one we used in f of f. So your domain would be from negative infinity to 0, union with 0 to infinity. That right there, the domain of a composition function, is one of the hardest things that we look at. So if you need to YouTube it, you need to go back and look at your book, you might want to do that. Do your homework. I will post my homework for you to check your solutions. All right, let's finish this set of notes. So I don't really like the title of this example. It says show that two composite functions are equal. If you really read it, they give you an f and a g. And what they want us to show is that f of g of x is equal to g of f of x, but that they both turn out to be x. And they're getting us ready for inverses, which is our next section. So they want us to compose these two functions both ways. So let's do f of g of x. Notice I'm using the other notation just for fun. So what does that mean? It means I'm going to plug my g function into my f function. So that would be 2 times 1/2 x. And if I do the algebra, that's going to be x. So we showed that f of g of x is equal to x. Now we want to show that g of f of x is also equal to x. Well, what would g of f of x be? That means I'm going to plug my f function into my g. So if I plug my f into my g, that's going to be 1/2 times 2x, and simply 1/2 times 2x is also x. So not only did I show that the compositions were equal to one another, I showed that they were both x's. Let's do another quick one of those. Same thing we're doing. So the first thing we're going to do is we're going to find f of g of x. So let's plug my f into my g. So it would be 1/2 times 2x plus 1 minus 1. And if I do the algebra, that's 1/2 times, well, those cancel, 2x, which is x. So it works that way. Now let's find g of f of x, which means I'm plugging my f into my g. So that would be 2, no it wouldn't, yep, 2 times 1/2 times x minus 1, and then plus 1. Oh, well, let's see. 2 times, if I distribute this through, I'm going to get 1/2 x minus 1/2. If I distribute through the 2, I'm going to get x minus 1 plus 1, and lo and behold, I get x both ways. That's what they're asking you to find there. And last but not least in this section, they are going to give you the composition function. So it says find the two functions, the two original functions, f and g, such that when I compose them, I get my capital H function. So this is the composition. So now they want you to find the f and the g. Well, let's start off with this. I'm looking for two functions. Here's the easiest way that I can think of this. If you look at how they write it here, the g is being plugged into the f. So I want to look at this function and don't overthink it and want to ask myself, what does it look like was plugged into another function? Well, to me, that means it looks to me like the 2x plus 3 was plugged into something else, some x. So that's my plugging in function, so that's my 2x plus 3. If I take that out and put back the original x, my f function would be x to the 4th. Now just check it. If I were to find f of g of x by plugging g into f, do you see that this is what I would get? There's more than one answer to many of these. This one, I don't think there's really more than one answer. Let's look at this one. This is my composition. So I want to find the f of x and the g of x. And again, the g of x is what's being plugged into the f. So if I look at this composition function, to me, what looks like it's been plugged in for something else is the 2x squared minus 3. That looks to me like it's been plugged in for something else. And if I take that out again and replace it with my x, my original function was 1 over x. And again, if I were to quick check this and find f of g of x and plug g into my f, you can see I would get the composition function. And that's the end of 5.1.